Some of them making some noise. Please make sure some sound is coming. Thank you. Yes, this is a fluorescent lamp, right? So usually we are providing fluorescent lamp with the two terminal supply. One is a phase and another one is a neutral. Just usually, so which side we are going to connect ballast or choke? This will be called as ballast or choke. So that side only we have to connect a phase cell. Right? So phase we have to connect, and this side we have to connect usually normally neutral. So which side we are going to take the ballast or choke? So we have to go. So automatically this is a phase terminal and this is a neutral terminal, two terminal connection to the power supply. Okay, so from there it is going to be a ballast, so which is having another two terminal. So this is going to be incoming and it is going to be outgoing. So automatically it is having a two terminal. One is used for incoming from the base and another for outgoing. So that terminal is connected to the fitting. In fitting, we are having a fluorescent lamp holder. So usually that will call it as a left side holder and right side holder. So left side holder or right side holder. So that also having one side in a two terminal. Okay, so the two terminal. So what is the outgoing wire from the choke? It will be connected here. It will be connected here. So until the tubeless is connected, it will be open only. So when you are connected to the tubeless, so automatically, if you see that in video, I say a vertical opening will be there. In that, we will insert the two terminal of the tubeless and we will rotate in the clockwise direction in order to make it lock. So once it's locked only, automatically the terminals will be connected. So this is one terminal and second terminal will be here. So when we are inserted vertical way, we are inserted the tube light in the holder and we are making it to a clockwise direction. There will be a lock. A small sound will come. So it will be locked. So from that, it is connected to a starter, a terminal called starter. Okay, this is a biomechanic strip. Automatically, when a very high current goes, it will be melt. Okay, so automatically it will connect. Then a small amount of time, current is not there, it will be once again it will be cooled and open. So when the current is go high, it will be melt by metallic strip like that. Okay, so automatically it will be closed. So this is once again connected to the right hand side terminal 2 of a fluorescent lamp holder, and right hand side one terminal also will be there. The same way, when we are inserted the tubeless, so these four terminals okay will be inserted in the left hand side and right hand side terminal vertical way. So automatically when we are rotating the clockwise direction, both in the left hand side and right hand side holder will be locked. So by that the connection will be made. So until that this will be open circuit. Until that will be open circuit. So automatically, when the supply is given, okay, so usually, so here one switch will be there. From phase, we'll have one switch like this, okay, and this will be. So automatically here it will be open only. When I close the switch, what will happen is current will be flowing. Okay, it will be going through that, and it will be going through the filament also. It will be going through the filament. So what will happen? So because as far as the ballast is concerned, it is simply made up of a winding zone. You see the inside the ballast, I am using a L core. L core means it will be like this. L core. The iron core will be there, which will be in the shape of L. A very, very thin core will be there. So I am having another one L core like this. Okay, so say for example, it will be like this. Okay, the iron core will be like this. Okay, same thing. If I am keeping it upward direction, okay, it will be like this. So I am having a combination. So one L core from here and second L core will be like this. I am keeping one over another, one over another. What will happen is it will be looks like this. Way it will be like this. It will look like this one. So once a combination of two cores over, it will be like this. So likewise, I am repeatedly having a n number of such a cores, iron cores, one over another. Okay, so with the proper insulation and all. Then after I made that, I will make a winding. I will make a simply make a winding. Okay, over the particular core, which will be very bulge in nature. Okay, so automatically I will make a winding over that. Then I am having a two terminal. One is one. Okay, this is a terminal one, which is going to be incoming, which is going to, that is what here. Okay, this is what here. This is what here. One and two terminal. So inside the ballast, inside the choke, I am having a L core. Okay, so I'm just having opposite direction one by one, so it will make a closed core. Likewise, I am having a n number of cores one over another. Okay, with the proper insulation and all, then I will make a wind. So if a current is passing through, so automatically what will happen when I'm giving the when I close the switch, automatically current will be passing through this one. So this will make mutual inductance, self inductance and mutual inductance both will be coming. So whenever a current carrying conductor is wounded like this, okay, automatically in a normal current carrying conductor itself, there will be a magnetic field around that. Okay. Suppose whenever I'm having a coil-like structure, because of that, it is having a magnetic field. That magnetic field, okay, it will produce a magnetic field over here. Okay, so that will be cut by the windings of here. Windings of here. That also carrying the same current. So whenever there is an induced EMF, that induced EMF will be once again will be induced EMF in the primary. So it will be this will be acting as a some primary and secondary. What is happening is both are in series. Both are in series. Suppose this is a primary. So this flux will be linkage with the secondary coil, but it is also in series with it. It is also carrying current. So because of that, a small amount of self and mutual inductance. At that time, what will happen is here circuit is going to this current. Earlier, it will be in a closed stage. Starter will be in a closed stage. So if you see that, if you see the current, this will be going to balance. This will be going to a filament, and this will be going to starter. That will be the closed stage first. So it is like a short circuit. It is like a short circuit. Through the ballast and filament and starter, it will be like a short circuit. As a result of that, very huge amount of current will be going. It's all happening in a fraction of a second. Okay, huge amount of. So when a huge amount of current is going, the magnetic field strength also will be huge because of the self and mutual inductances here within a fraction of a second, 1,000 voltage will be induced. 1,000 voltage. Approximately 1,000 voltage will be induced in the choke. So if you see that this is a terminal in which a particular voltage will be applied. Likewise, here also in this terminal also is applied. So when 1,000 voltage with a huge current is applied, this filament already it is having some electrons because it is heated. Because of the high current is going through this filament is getting heated. Some free electrons will be available. So in addition to that, this 1,000 voltage also available that make inside the fluorescent lamp. Okay, what is the gas? It is discharge. That is making it is ionizing the particular one. So automatically this will be making a conduction. So So now electrons are available. These electrons has to go this direction. To reach this right hand side folder filament. So how it is possible? If the gases get ionized only, it is possible. That gases is ionized by means of 1000 voltage that is induced here. So because of that, now the conduction is made and current is flowing through this one, this direction. Because of that, there is no any current is flowing through starter. Now it is available because of this gases get ionized. Now it is a path is available inside the tube. So there is no any current flow. Automatically it will be open. Okay, it will be slightly open. Okay, so because a heavy current is going, it is slightly melted and it is open at exactly at the same time. The voltage induced here is 1000 voltage that makes facilitating the conduction. So even once the three plates start conducted, even if you remove the starter, that plays doesn't play any role in that. Okay, because there's no any current. So once it's cooled, once it's cold state, if you place the starter, it will be the closed state. So now because of heavy current is flowing, it is metallic state like that, it will be slowly. Earlier it is facilitating high current, then it is open also. Before it is opening, that high current facilitates the electron and also it facilitates the induced EMF on the choke is very high. Okay, now the current will be coming down. Okay, because it's passing through the gases, its own resistance will be there. So now the current will be coming down. Because the current is coming down, the voltage induced also will be coming to a normal voltage. So this 1000 voltage will be induced in the inside the ballast or choke for the fraction of second, approximately 0.8. That's why when you are immediately switch on, automatically what will happen? A small flickering is come. Now it's made that the choke and all design in such a way that no any flickering right away in giving. So 1000 voltage is applied. So a starter flickering is nothing but because of starter. Because starter is in a melted bimetallic stick, so automatically it will be melting and contacting. It is like a contacting and closing and opening the contact. So because of that, so here a fraction of second, okay, 1000 voltage induced, that induced voltage is applied across the gas inside the first lamp. That will be making ionization of the gas because electrons also available in both the ends. That ionization make facilitating the conduction. Okay, so that's the reason the fluorescent lamp is blue. So what is the advantage of fluorescent lamp compared to the incandescent lamp is here if you see that it is completely flow of electron inside the gaseous environment. Automatically, what is the resistivity offered by the only? It is given. Okay, so if you see, if you touch the fluorescent lamp surface, outer surface, even after the long time of working, 10 hours to 7 hours, there won't be any heat. There won't be any much amount of heat compared to the incandescent lamp, where if you touch the incandescent lamp, even after 1 hour, so you may be getting a burning. Okay, burning tissues may be burning and damaging. So you cannot touch with a fair hand or you cannot remove the incandescent lamp from the holder. Okay, simply like that. Okay, so that's not it. So automatically it is only producing whatever the energy we are taking here. It is only producing the light inside. But if you see that it is the ballast has to be continuously in the operation. Unlike starter I can remove because after the fluorescent lamp, okay, gases get ionized and it facilitates the current conduction inside there. Starter doesn't play any role. I can remove the starter, but whereas the ballast, if you see that the current is going through the ballast. Okay, even though it doesn't play any role in the continuous conduction, the ballast. So because of that, a small amount of losses is there. That is what we have removed in the case of a compact fluorescent lamp or LED lamp, it is completely removed. LED, there is no need of any choke like that. Okay, so this is what happened. So we will see a video, okay, small video, which facilitating that. You can able to understand how to do the connections. You see, this is in order to give a connection, usually we need three important instrument. One is a cutting plate, that is a wire cutter. Okay, so what is the first component we will see? Okay, it's a choke. This is called choke. I told you inside that we are using a L iron probe. So and this is a lamp, fluorescent lamp. So the particular choke is attached to a metal. Okay, so put together this metal strip and as well as choke is called fitting. And there is a one more is there called starter. This is a starter holder. So this is a starter holder. So as like that, there is a two terminal in. Okay, so it's a starter holder, and this is the left hand side fluorescent lamp holder. It is also having a two terminal. Likewise, a right hand side terminal also having a two terminal. Two terminal. Okay, so if you see that inside that there is a vertical strip is open through that we have to insert it. This is called fitting. So choke and as well as metal. Okay, so strip like this. So this is for the fluorescent lamp diagram. Okay, so as I already explained, okay, so there is a phase from the phase switch is there, switch to choke is there. From choke, it is going to be a filament and starter also is connected. Okay, so in the fluorescent lamp, there is a four terminal. Okay, left hand side two terminal, right hand side two terminals are there. And also using a on off switch, I can able to connect the particular 230 voltage supply, okay, to the particular fluorescent lamp. Okay. So usually the particular switch will be connected, okay, in series with the choke, in series with the choke input terminal. So as a choke is a two terminal, we can use either terminal as input or output. It's a rule is there because inside there, if what is the current type goes accordingly, there will be a voltage will be increased. In filament also, if we are having a two terminal, from the outgoing filament of the left hand side photon, it is connected to the starter. It is going to be starter, and neutral is going to be simply having a only one connection, one wire that is going to be a right hand side terminal. So right hand side filament second terminal is connected to the another end of the starter. So this is how the entire circuit connections we are going to give. Already, if you purchase outside market, what is a fitting? Okay, two-plate fitting. Already it will be there. You will have only a two-terminal output. Okay, usually in the wire, the color is red and black. So red means phase connection, and black means neutral connection. If you see there, there will be a wire connector. It's wire it connected to a wire connector. Through the from there only, it will be going to the inside the circuit. Inside the circuit, automatically the red wire is connected to the phase terminal. That is where the wire is going to ballast or choke. Whereas a black wire is going to connect to the wire which is coming from the right hand side filament of the tubeless. Okay, right hand side filament of the tubeless. If you see that what green wire is going, okay, from the phase, it is straight away going to one hole. If you see that hole, it is going to the input terminal of the choke. Okay, one green wire. Okay, then another one wire is green wire is coming out. If you see that where that wire is going, that green wire is simply going to the where it is going to the filament. Okay, filament of that. So two terminal filament is there. So one terminal filament one left hand side filament one. If you see that one pink wire, you see that closely see one pink wire is there that is going to be connected to the another one filament. Okay, so filament having two terminal, one and two. So if you see the pink terminal, pink wire, that is going to be from the coming from the terminal two, which is going to be connected to the starter. Okay, which is going to be connected to the starter, and from that starter, it is going to be a next filament, right hand side terminal filament. From the right hand side terminal, second terminal, it is connected. Okay. From the first terminal, if you see that one wire is coming, once again a green wire is coming. That green wire will be coming to the neutral supply. So you see that. So second terminal, starter wire is connected. If you see another one green wire, that is going to be come to the terminal of the neutral. We are going to connect this. So this is how in fitting it is normally in commercially available fluorescent lamp. Up to this end, if you are seeing a block connector, up to that it will be available. We have to connect one red and black wire. Okay, so in order to distinguish that, red is meant for phase and black is meant for neutral connection. Okay, so this is how we have to understand the wiring of the person. So if you see that the terminals, okay, the left hand side holder and right hand side treatment holder, okay, so that green wire is going to inside and pink wire is going outside from the terminal 2 of the fluorescent lamp. So that will be once again going to the second terminal of the right hand side holder. From that first terminal, it is going to be connected to the neutral of the wire. Okay, so that is what here it is displayed. So now, now we will give the connection. We can take a lamp and we have to keep it in such a way that the two terminals, that inside the pole, inside the rotating part is there. So that is having a vertical in both the terminal, both the side, left hand side folder and right hand side folder. We have to ensure that that is in the vertical position in order to insert the filament terminal of the tubeless. So I have to be carefully connect that, and I have to rotate right side in order to make lock. So if you rotate right side, yes, one click sound will come. That will ensure that the particular tube light is now locked. Now I am going to give a connection through a fluorescent lamp. Now I'm going to give a connection. So, okay. So in a supply side, I'm just using a test lamp setup. Test lamp setup. Why I'm using a test lamp setup is whenever I'm connecting in a circuit, so whether the circuit is closed or not, I can able to understand test lamp. But actually, in a normal application, we won't use any test lamp. Straight away we connect. So why I'm here use the test lamp connection is, so whenever a tube light is working, sometimes we may not identify that whether the tube light is working or not. Okay, so in order to know that, I'm using a test lamp method. That is the reason why. So I am having one incandescent lamp that also will be glowing. If you see that glowing, so we can able to understand whether it is properly working or not. Okay. Now, as I already told, so now we have fitted the tube light. Okay, in the particular left hand side folder and right hand side folder simultaneously, and I ensure that it is inserted and rotating in the clockwise direction. Okay, and make a click sound that makes that ensures that particular lamp is locked. Okay, properly inserted. So now I am giving a wiring phase and neutral to the supply. Okay, so which is connected to, if you see that I am having a test lamp connection. So if you see that, okay, whenever I switch on the light, it will be immediately on. So I here the starter is not connected. That is the reason that it is not glowing. So starter, okay, starter is inserted. So now if you see the lamp is glowing. Lamp is glowing. So now the starter role is over. Starter role is over. So if you see the lamp, how whether the tube light fitting is properly working or not, I can able to see. Okay, so if you see the lamp, initially it go bright, then after that it will be dim. See that once again I switch off. You once again see that initially it will go bright and up. So that means initially the choke voltage, I said in a fraction of seconds. At that time, so my incandescent lamp also seriously connected. That's the reason why it is go bright then dim. So that means the complete fitting inside the including lamp and everything is properly. Okay. So now I'm replacing that with one faulty starter. Okay, now it is completely bright. If you see there, okay, so it is not dim, but fluorescent lamp is not working. So this is a way I can able to identify that. So my starter is not working. The starter part is there because through the test lamp I can able to identify that. So there is some part. How to identify? Because test lamp is continuously okay, glow bright, very bright. Okay. So now I will once again replace that with correct, okay, good working starter. Okay, good working starter. Now it is glowing. Now it is glowing. So this is how we can able to connect fluorescent lamp wiring and we can able to check whether it's properly working. So only thing is I have to use a test lamp. So if you use a test lamp, that will be initially bright, then after that it will dim. If it is continuously bright, circuit is good, circuit connection is okay. Maybe due to the starter, it is not. That's the way we can able to understand. Okay, so how the fluorescent lamp. So now the fluorescent lamp connection is over. Any clarification?
No, sir.
No. Okay. So now we will see how to check. So all the choke, all the fluorescent lamp. So as I already told, there are some very often we are encounter the situation, facing the situation that we have to identify which is a part because as I already told, it is a complete fitting, consists of lot of components, including a wiring, and we are having a starter, we are having a choke, we are having tube light with filaments, that's four terminals. So which is wrong. So if a tube light fitting is not working, we have to identify that. So this is a method I am going to explain. What are the methods? So the same test lamp arrangement is there. Test lamp arrangement is nothing but I can able to tell you that is if I am having a usually what is a test lamp arrangement is I'm having a wire connection. Okay, so which I'm having a I'm having a wire, I'm having a bulb. Okay, so these terminals, after that only, suppose I'm having a phase, I'm having a phase, I'm having a neutral. Okay, so these two terminals only will be available through switch. So I'm having a switch. Okay, so I'm going to connect. So whenever a circuit is open, it will not be glow. Whenever circuit is open, it will not. This is called Tesla. So here only I'm going to connect. So as I already told, for a tube plate fitting, okay, for a tube plate fitting, this is going to be act as a second power source terminals. Okay, so even though I'm having a tube plate fitting now, I'm connected. No? Now I'm connected to phase and neutral means if properly working means earlier what will happen? This bulb will be getting dim, bright, then continuously dim. So now due to the starter fault, if there means it will be continuously brightly working because circuit connection no problem, but startless problem. So it will be continuously brightly working, but tube light is not glowing. So that's the way we can. This is a test lamp arrangement. From phase, I'm connecting one lamp. That terminal is taken and neutral terminal is taken. So whenever your load is properly connected, close to circuit available, then only this will be working. This is the concept of test lamp arrangement. That is what we are here. We are seeing the test lamp arrangement. See. So I'm giving a supply. This is a terminal which is it is an LED. Okay, which indicates that this is getting power. But this lamp is connected through a wire in series with the switch, as I told, as I drawn here. So how to check that? So if I'm having a open-ended wire, if I'm connected that wire, this will happen. So it is a base neutral wire. A base neutral wire is there. It is cut wire. It is now open circuit. Now if I'm making short circuit, then the lamp will go. That means circuit is closed. So this is a starter. How to check a starter? I told you no. So if you connected there, if you see that a small flickering is coming, you see the lamp, a small flickering is coming. So this starter is good. Okay, whenever you want to test the starter using a test lab method, okay, so I have to use, okay, so one lamp, which is maybe a 40 watts lamp. If I'm connected there, automatically what will happen? A flickering will occur, continuous flickering occur. That means starter is good. Okay, so see a faulty tester. So I am replacing a faulty tester. Okay, so it will be continuously bright, no flickering. That means it is permanently inside the starter. It is awesome. Sometimes it is permanently open means there won't be any. So normal and good working. So good working means this is it. If you see that the flickering is there. So how to test the starter is this is a good way. A continuous flickering will come. Okay, bimetallic strip will be on, and because of the huge current, it will be okay. So open. So if you see, this is how normally working. This is how when we are connecting a good working. Okay, so I can able to identify that starter is called two-way. Okay, one is through starter if you have connected there, a continuous bright lamp is there means permanently inside the short circuit bimetallic strip is not working. So there is no flickering. Other way, lamp will not glow. So permanently it's open, even though supply is given, there is no any current. So these are the two conditions I can able to understand that starter is fault, starter fault. Huh? This is a faulty one. Continuous bright, no flickering. It means my starter out. Okay, so we should not misunderstand the starter circuit. Sometimes what will happen is due to a nervous hand, our hands are okay, we have to stay. So we should not misunderstand that start is good. Okay, so we have to keep it in that way. So usually this type of testing should be done by a electrical engineer, those who are familiar with it, because you open your hand, okay, so we without using gloves and all, we should not do. That's a precautionary measures because electricity is a very good master, but good slave. If you are properly used with all the rules and regulations, the safety measures, if you are using electricity, it is a very good slave. You can do whatever the thing, but very bad master if you are not following the safety rules and measures. Immediately a fatal end. Okay, so usually normally what they are saying is even 20-25 volt with 1 ampere is capable of killing. If you are not properly used to insulated yourself with the shoes, okay, with the rubber gloves. So usually we are saying that electricity is the very good slave but bad master. Okay, so this has to be practiced. Okay, so after knowing the several procedure safety measures and all only you should practice like this. But this is a very best method to identify the faulty count. Okay, start with fault and all. We can identify very easy. The next we are going to check the choke. Okay, what is a good choke? Okay, and what is a bad choke? If there is a good choke means automatically if we inside there, okay, it will be very it is glowing. Okay, it will be glowing because inside the small okay, so it will be glowing. So this is if it is continuously without anything, it is continuously glowing means, okay, now I am testing. Now I am testing the lamp, testing the soap. Okay. So actually, what should the right soap? Initially, it should glow. Initially, there should be a light voltage, so that will be making it glowing. Okay, now the particular soap is not giving anything. So inside that it is series connection only. Inside that, as far as the electricity concerned, it is a series connection. So automatically what will happen? Induction will be stored energy. Okay, at that time, initially bulb will take, after that lamp only will take. Okay, so the bad choke will not give any output means choke output. Likewise, terminal. When we are going for a filament terminal, we have to properly use the lamp patch. So here I am using a 40 watts lamp. 40 watts. So for that, if it is a 200 watts bulb, okay, if it is a 200 watts bulb, I can able to very easily visualize it. So changing of the test lamp also is useful one for me. So I am now using a 200 watts lamp. For a 40 watts lamp, so you see that very brightly it is glowing. Okay, I am testing that. Now, in order to see inside the filament is working or not, we have to use that, because if you see now, okay, the filament, you see that inside the filament is working. So if black painting is there, if no any glow inside the filament means that will be damaged. So uh, filament is damaged. So now it is good working. So in order to get that inside that light, we have to use a high power test lamp. High power test lamp. See that, okay, so the filament is working. So we have to do this test for both the end of pipette. Okay, both the end of pipette. So it is because why I am using a 200 watts bulb means 200 watts bulb automatically draws more current. If more current is drawn, the filament will be heated more. Free electrons available will be glowing. So automatically, if we try to ionize the gas near say the filament, I can able to. This is how incandescent lamp can be tested. So for 40 watts incandescent lamp, I'm using a 200 watts bulb. So that is why I'm not able to visualize it. In order to check that, I'm using a 100 watts for 40 watts incandescent lamp. Means I have to change the lamp to once again to a 100 watts lamp. A slow, a mild filament lighting will be there. That will be ensure that the particular lamp is working. So whenever I'm testing the incandescent lamp, I have to use, okay, so usually for incandescent lamp, there is no need of any testing methods also. But when you want to test a series connection, close. Okay, next we are going to see incandescent lamp. Incandescent lamp that we have seen that. Okay, so in order to get that, I am replacing that with that. So now is very important is CFL. Okay, compact version. When we are using a compact version, this is also very often happening, whether it's working properly or not. For that also, I have to use, okay, double the time, very less. Suppose 14 watts means I have to use only 40 watts. Now, I'm for a CFL lamp testing, I'm only using a 40 watts lamp. Then only I can able to identify whether it is working or not. If you're giving the connection, lamp is working. So inside the fluorescent incandescent lamp, you see that a minute line is coming, minute illumination is coming. That means it is working good. Fluorescent lamp is good. Okay, in 40 watts, so we have to double the power. Fluorescent lamp is approximately 14 watts means we don't have any 28 watts incandescent lamp. So that's why we are using the 40 watts lamp. Okay. So this is how we can able to check, okay, the connection. So now how to test it, how to test especially the capacitor. Okay, capacitor. So usually we won't connect. We will remove the plug and terminal. We only using it in the socket itself. We are using. Usually we will charge. Usually you know that whenever I am connecting a capacitor, whenever I am connecting a capacitor, what will happen? It will be getting charged. So you have to start after 1 or 2 seconds. You have to completely remove the capacitor from the terminals, and I have to make it short circuit. If it is a very small sound only is coming means automatically okay. So if it is very small, some short circuiting sound it comes means capacitor is gone. Very large amount of sound is coming also, it is good. In that case also, if I am using a 40 watts lamp, 40 watts lamp will be very initially it will be very bright. Then now after that it will be dim. Okay, then the capacitor is properly working, proper good condition. Like that, we can able to troubleshoot them. Okay, so this is how we can able to we can able to conclude that. Okay, so now are you all able to understand how to give connection fluorescent lamp and a connection, how to troubleshoot any problem. Okay, so with that, so now only thing is I will forward on material regarding the fluorescent lamp connection and all. You just make it as an experiment in which normally how a fluorescent lamp wiring diagram and the extra will be there, and how to troubleshoot starter, choke, and as well as wiring. Okay, so these are all the things will be there. You just make a copy of your own. Okay, in choke, what is the condition? Whether choke is damaged, okay, so are working properly. Everything will have a two conditions will be there. So in that also you have to record it. Okay, so you have to write and you have to, as usual, you have to upload. Okay, in our class note. Any clarification?
Yes, sir.
We will take attendance. How many of you present? How